All right, here are your guided practice 3, your practice problems for the fundamental theorem of calculus. The two things you're going to be asked to do here is to find the derivatives of an integral, okay, and to evaluate an integral. So we're going to find the derivative here of f of x in number 1. And remember that the fundamental theorem of calculus part 1 tells us that the derivative of the integral is what's inside. So that tells us that f prime of x, I will lose the integral, and I replace the dummy variable, the dt, with my x. So this is going to be x over 1 plus x cubed. And my upper limit is just a plain old x, so I don't need any chain rule or anything extra. In number 2, we're going to do the same thing. We're going to replace our t's with this sine x, but we will have to use our chain rule. So the derivative here, f prime of x, take the derivative of an integral is what's inside. So I'm going to plug in the sine x wherever I see a t. So 1 minus sine squared x over 1 plus sine to the 4th x. But because this is not just an x, we've got to use the chain rule, which says multiply by the derivative of that. And the derivative of sine is cosine x. So that's our derivative. When you get to number 3, you're being asked to evaluate an integral. So whenever it just has an integral sitting there, you're just finding the value of the integral. Remember that when your boundaries are numbers, you're going to get a value, not a function. And we want to use the second part of the fundamental theorem of calculus to take the antiderivative here and then evaluate at our boundaries. So this is going to give us, let's see, 2x to the 4th is the antiderivative, plus x cubed, and I'm evaluating that from 1 to 2. When we evaluate that from 1 to 2, you're plugging in 2, so 2 times 2 to the 4th plus 2 cubed, minus when you plug in the lower boundary, so plug in 1 is going to give you 2 plus 1. So you're taking, let's see, that's going to be 2 to the 5th, because I've got 2 times 2 to the 4th plus 2 cubed, minus 3 gives me 37. This was 40, and this is 3. For number 4, okay, the tricky part here is a little bit of simplification to find your antiderivative. So before I do anything, I'm going to rewrite this as u to the 1/2 minus 2u squared all over u. And as of right now, we have no techniques for managing the division, so I'm going to have to divide that through. So I'm going to have u to the 1/2 over u minus 2u squared over u du. From there, I'm going to simplify each part. So I simplify here. That's going to give me the integral from 1 to 9, u to the negative 1/2, right? Because you subtract exponents when you're dividing. So 1/2 minus the 1, that's right there, gives you negative 1/2. Minus, when you cancel the u's over here, that's 2u du. And now I'm ready to go ahead and take my antiderivative. So now I can drop my integral sign because I'm taking the antiderivative. So I'm going to add 1 to my exponent, which would be u to the 1/2, and I'm going to divide by that new exponent. So dividing by 1/2 is the same as multiplying by 2. And then minus u squared, and I'm evaluating it from 1 to 9. So I'm going to plug in 9 first. So 2 times the square root of 9, because u to the 1/2 is the square root of u. Minus 81 is when I plug in 9. Minus, plug in 1. So 2 square root of 1 minus 1 squared. And that's going to give me, let's see, 6 minus 81. And then over here, I'm subtracting, that's going to be 2 minus 1. So I'm subtracting 1. So you're taking a positive 6 minus 81. Minus 1. And that gives you negative 76. Okay, again, you're getting a value. So the key thing when things look a little bit more complicated is to simplify it in terms of power so that you can take your antiderivative. For number 5, it's going to be similar. So I'm going to rewrite this. I'm leaving it as 1 over x because 1 over x is special. And then minus x to the negative 2 dx. When I go to find my antiderivative, that becomes the natural log of absolute value of x minus increase the power by 1, that's x to the negative 1, and divide by negative 1, so that will become positive. And we've got to evaluate that from 3 to 5. So that's going to give us the natural log absolute value of x plus 1 over x evaluated from 3 to 5. And that's going to give us the natural log of 5 plus 1/5 minus, plug in the 3, the natural log of 3 plus 1/3. And that will turn out to be the natural log of 5 plus 1/5 minus the natural log of 3 minus, because you're distributing the negative, 1/3. And that gives me 0.377. And then lastly, for our guided practice, we've got some trig functions. And nothing crazy here. Antiderivative of sine is cosine x, but negative. And then minus antiderivative of cosine x is sine x. And you're evaluating that from 0 to pi over 2. So you're taking negative cosine of pi over 2 minus the sine of pi over 2 minus when you plug in 0. So negative cosine of 0 minus the sine of 0. Okay, and we know, let's see, what do we know? We know that the sine of 0 is 0, so this one's gone away. And we know that the cosine of pi over 2 is also 0. So really what we're getting here is the negative sine of pi over 2 plus cosine of 0. Cosine of 0, of course, is 1. And sine of pi over 2 is also 1. And so you get negative 1 plus 1, which is 0. Which is a fun little ending to our guided practice problem.